Scientists have been watching this volcano for decades, and what they have found terrifies them. Somewhere beneath the surface of the Earth, pressure has been building, slowly, silently. The mountain sitting on top of it is not just a mountain, it is one of the largest volcanic systems on the planet, and it is overdue. Most people think volcanic eruptions happen far away. Indonesia, Iceland, some remote island chain that barely shows up on a map. But this one sits underneath one of America's most visited national parks. Millions of tourists walk above it every single year, taking photos, feeding geysers, completely unaware of what is sleeping beneath their feet. This is the story of Yellowstone. And it is not the story you have been told. Let's start with something that happened not too long ago that almost nobody remembers. In 2014, a section of road inside Yellowstone National Park literally melted. Not cracked, not buckled, melted. The asphalt turned into something closer to liquid because the ground underneath it had gotten so hot. Park rangers closed off the area. Scientists scrambled for explanations. And then, quietly, the story disappeared from the news cycle. But the data didn't disappear. Beneath Yellowstone sits a magma chamber so massive it strains the imagination. Researchers have mapped it using seismic imaging, and what they found is staggering. The upper magma chamber alone stretches roughly 90 kilometers long and 30 kilometers wide. Below that, a second, even larger reservoir, about 4.5 times bigger, was only discovered in 2015. Nobody knew it existed until then. Think about that for a second. Scientists had been studying Yellowstone for decades and still found a new, enormous magma reservoir hiding underneath the one they already knew about. That is how little we actually understand about what is going on down there. And here is where the story gets uncomfortable. Yellowstone is what is called a supervolcano, not just a regular volcano, a supervolcano. The difference is not just size. It is the kind of eruption it is capable of. A typical volcanic eruption might throw a few cubic kilometers of material into the atmosphere. When Yellowstone last fully erupted, roughly 640,000 years ago, it released approximately 1,000 cubic kilometers of rock, ash, and gas in a single event. That is enough material to bury the entire state of Texas under several feet of debris. And it has done this not once, but 3 times. The eruptions happened approximately 2.1 million years ago, 1.3 million years ago, and then again 640,000 years ago. Scientists have noticed a rough pattern there. Somewhere between 600,000 and 800,000 years, separate major eruptions. Do the math on the last one, and you will see why some researchers have started paying very close attention. Now, and this needs to be said clearly, the United States Geological Survey does not believe a massive Yellowstone eruption is imminent. The probability of a full supervolcanic eruption in any given year is extraordinarily low. But extraordinarily low is not the same as zero, and the consequences of getting this wrong are not something anyone wants to think about. Because here is what a full Yellowstone eruption would actually look like. The initial explosion would be almost impossible to comprehend. A column of ash and gas shooting 30 to 50 kilometers into the stratosphere. The blast radius in the immediate area would be unsurvivable. Within hours, the ash cloud would begin moving. Depending on wind patterns, within 2 days, ash could be falling across most of the continental United States. Crops would fail. Waterways would be contaminated. Roofs would collapse under the weight of accumulated ash. Electrical systems would short out. Aircraft would be grounded across the hemisphere. The global effects are where it gets truly dark. The ash and sulfur dioxide injected into the upper atmosphere would block sunlight, potentially triggering what scientists call a volcanic winter. Global temperatures could drop by several degrees for years. Agriculture around the world would be devastated. The food chain would fracture. Some models suggest a Yellowstone supervolcanic eruption could be the most catastrophic natural disaster in recorded human history. But here is what the news does not tell you. A full supervolcanic explosion is not the only scenario, and in some ways the more realistic threats are the ones flying completely under the radar. Yellowstone experiences thousands of earthquakes every single year. Most are too small to feel. But occasionally, swarms of earthquakes hit the region that are anything but minor. In 2010, more than 2,000 earthquakes struck Yellowstone within a single week. In 2017, a swarm of over 2,300 quakes rattled the park over the course of 3 months, one of the longest earthquake swarms ever recorded there. Scientists monitored it intensely, explaining that swarms like this are common at Yellowstone and do not necessarily signal an eruption. But the phrase "do not necessarily" is doing a lot of heavy lifting in that sentence. The ground at Yellowstone is also constantly moving, and not in small ways. The surface of the park rises and falls by inches every year as magma shifts and pressure changes underground. Between 2004 and 2008, parts of Yellowstone rose nearly 18 centimeters, almost 7 inches, in just 4 years. That is one of the fastest rates of ground deformation ever recorded at any volcanic system on Earth. Scientists call it uplift and say it is within the normal range of Yellowstone's behavior. Normal. For a supervolcano sitting beneath millions of people. Then there's the hydrothermal system, the network of geysers, hot springs, and steam vents that make Yellowstone one of the most visited places in America. What most tourists do not realize is that this system is directly connected to the heat source below, and it has been behaving in increasingly unusual ways. In 2018, a geyser called Steamboat, which had been largely dormant for years, suddenly reactivated and began erupting multiple times per year, shooting water and steam over 90 meters into the air. It went on to break records for the most eruptions in a single year. Geologists are not entirely sure what triggered it. The leading theory involves shifting water tables and underground pressure changes, but nobody can say for certain what it means for the system as a whole. And then there are the hot springs. Some of Yellowstone's most iconic hot springs have changed color in recent years, shifting from the vivid blues and greens that make them famous to murkier, cloudier shades. When scientists investigated, they found that debris and changes in water chemistry were disrupting the heat flow at the surface, minor on its own, but another data point in a growing list of things that are shifting at Yellowstone. The history of Yellowstone's eruptions is also more violent than most people know. Between the 3 major supervolcanic events, there have been dozens of smaller but still massive eruptions, lava flows, hydrothermal explosions, and caldera collapses that would each individually qualify as catastrophic by any normal standard. About 13,800 years ago, a hydrothermal explosion at Yellowstone created a crater more than 2 kilometers wide. No warning. No eruption in the traditional sense, just a massive underground steam explosion that ripped open the earth. These hydrothermal explosions are actually considered the most likely Yellowstone hazard in the near term. They do not require fresh magma. They can happen when the underground water system becomes superheated and suddenly flashes to steam, releasing enormous pressure in an instant. And unlike a volcanic eruption that builds for months or years, these can happen with very little warning at all. The monitoring systems in place at Yellowstone are genuinely impressive. The Yellowstone Volcano Observatory runs a network of seismographs, GPS sensors, and thermal cameras that track the park around the clock. Data streams in continuously. Scientists analyze every tremor, every ground shift, every change in gas output from the volcanic vents. If something big starts building, the system is designed to catch it early. But here is the honest problem with that. The 2004 to 2008 uplift event, the fastest ground deformation ever recorded there, was detected, monitored, and analyzed. Scientists watched it happen in real time, and they still could not say with certainty what it meant or whether it was a precursor to something larger. Yellowstone does not follow a simple script. It does what it wants, on timescales that do not fit neatly into human planning horizons. Japan built its tsunami warning system after disasters killed thousands. Hawaii built coastal infrastructure after waves wiped out entire towns. The lesson history keeps teaching is that humans prepare after the catastrophe, not before it. Yellowstone hasn't reminded the modern world what it's capable of yet. The last time it fully erupted Our species was barely recognizable. There were no cities, no infrastructure, no global food supply chain to collapse. The world that would face a Yellowstone event today is completely different from the one that survived the last one. And the uncomfortable truth is this: there is no evacuation plan for a Yellowstone supervolcanic eruption, not a real one. The area around the park would be devastated too quickly and too completely for traditional emergency response to function. FEMA has acknowledged that a full Yellowstone event would exceed the response capacity of any existing disaster framework. Scientists say the best preparation is monitoring, catching the signs early enough to give surrounding communities weeks or months to relocate. But weeks or months assumes the volcano gives a warning at all. Some of the most dangerous volcanic events in history gave almost none. Mount St. Helens in 1980 had weeks of warning signs before it erupted, and even then, the scale of the explosion caught scientists off guard. The northern face of the mountain collapsed in seconds. A lateral blast leveled 230 square miles of forest in under 3 minutes. Yellowstone makes Mount St. Helens look like a campfire. The ground is breathing, the data is shifting, and most of the country has no idea that one of the most powerful geological forces on Earth is sitting right underneath one of its most beloved national parks, restless, ancient, and deeply, fundamentally unpredictable. The ocean has proven it can surprise the East Coast when nobody's watching. The ground has proven it can move in ways nobody predicted. And Yellowstone? Yellowstone has already shown the world 3 times exactly what it's capable of. The question was never if, it was always when. If this kept you up a little, wait until you see what's coming next. Hit play on the video showing up on your screen right now.